You're most welcome. Today I'm gonna teach you uh, adrenal cortex and its hormones. All right, adrenal cortex, the outer part of the adrenal gland, call it suprarenal gland, secretes a couple of hormones, and I want to talk about them today. Yeah, all right, let's continue right away. David Stevenson Theater. Gmail.com. You can contact us. All right, so don't forget to like our videos, subscribe, share to more and fellow students to also enjoy the science we give. All right, contact, contact. And let's begin with the simplified structure of the suprarenal gland. As you can see here, we have the kidneys. This is a left kidney, then this is the left adrenal gland. So we have this adrenal gland, its cortex, the outer part of that gland, secretes several hormones, which we are going to talk about today. The middle part or inside part is called the medulla, adrenal medulla. And this cortex has a couple of layers. As you can see here, it has 3 layers, distinct layers. Alright, so as you can see here, this is a full adrenal gland. This is the capsule of the gland. Then we have the zona glomerulosa, the outer part of the cortex, the middle part of the cortex, and the largest one is called the zona fasciculata. Then we have the zona reticularis, the profound part of the cortex. Okay, and this is the medulla. So there are layers of cells forming distinct zones within the cortex. Alright, so let's talk about those layers. That of a human has distinct layers and zones. And one is zona glomerulosa, which is like 1/5 of the cortex and secretes aldosterone. This is a aminocorticoid and corticosteroid. This is these two hormones are from zona glomerulosa. Then we have zona fasciculata. This is the widest zone at the center, and it forms like middle 3/5 of the cortex. The cells are 2-cell thick, straight columns. They have sinusoids in between, but this layer secretes what we call glucocorticoids. For example, cortisol. Alright. Then the innermost layer is the zona articularis, which forms the inner 1/5 of the cortex. It's a network of compactly arranged cortisol cells. So you can see here we had sinusoids and straight columns. These are called arranged cortisol cells. That's the origin of the name Zona Articularis. But secretes hormones, cells here secrete hormones called androgens. For example, DHEA, dihydroepiandrosterone. Alright, so let's talk about those hormones. These hormones are called corticosteroids, and they include 1, glucocorticoids, which is corticosterone and cortisol, and these have a widespread effect on glucose and protein metabolism. Then we have the minocorticoids. Yes, the glucocorticoids are from zona fasciculata. And then minocorticoids are from zona glomerulosa, the outermost, and of the cortex. And the aldosterone is the chief minocorticoid we know, regulates sodium balance and volume of extracellular fluid in the body. And adrenosteroids, they will include DHEA and this sulfate ester. These two are secreted by the zona reticularis. Let's continue. Now let's talk about cortisol. Cortisol as a glucocorticoid has a couple of functions. There are very many functions, and we want to look at this. It has a lot of functions in the body. It is produced in response to stress. We studied about stress a long time ago. But as you can look at this, cortisol decreases bone formation and increases resorption. So it means cortisol is activating the osteoclasts and inactivating the osteoblasts. So resorption increases. Okay. Then another function decreases connective tissue. The cortisol maintains cardiac output. It increases tone of arterioles and decreases endothelial permeability. Alright, so permeability of the endothelium reduces at capillary level. Then cortisol inhibits inflammation and immune responses. This is a very large topic to talk about, as we saw last time, that it has a lot of effects, inflammatory and immune response. It inhibits these two factors at a couple of stages. Okay, so cortisol also facilitates maturation of the fetus. The fetus to maturate, cortisol is a facilitator, and increases glomerular filtration and fluid water clearance. This is the same cortisol. Cortisol has also a function of modulating emotional tone and wakefulness. In stress, it is hard to sleep. Cortisol is also a participant of that, and maintains muscle function and decreases muscle mass. Because it is produced due to stress, it will cause degradation of the amino acids of the proteins within the muscle to get out amino acids for gluconeogenesis. So that's why the muscle mass will reduce. All right, let's continue. Those have been the effects of glucocorticoids on various tissues, organisms, and systems of the body. So let's talk about regulation of its secretion. Secretion of cortisol, as you can see, is regulated by this axis of hypothalamus, adrenal hypophysis, and adrenal cortex, which exerts its effects through the following. One, we have corticotropin releasing hormone. This is from the hypothalamus. Then we have adrenocorticotrophic hormone, which is produced by the basophils of the adrenal hypophysis. Then we have the glucocorticoid negative feedback effect. When cortisol is high, it reduces its own production by negative feedback. We have short loop, long loop, and ultra short loops. Those are negative feedback mechanisms, okay? So now we've gone to the mineralocorticoids. Mineralocorticoids, all right, we have aldosterone as the major mineralocorticoid we have, okay? By the others like deoxycorticosterone, DOC, this one here, DOC. Then we have 18-hydroxydeoxycorticosterone, 18-hydroxy-DOC. It's secreted in small amount and has some mineralocorticoid activity. So the chief is aldosterone. That's why we're going to talk more about aldosterone alone. Let's continue. So now we want to talk about regulation of aldosterone release. How is it regulated? If I have potassium load here, and it increases such that I have hyperkalemia, much potassium in blood, this one will stimulate the adrenal cortex, a zone which we call the zona glomerulosa cells, to release aldosterone. Okay, but if you also have deprivation of sodium, for example, sodium can be deprived in hemorrhage, or here we shall lose a lot of blood, and water will reduce also, and blood volume will reduce. Upright posture affects the blood volume. It is called threatens something. Yes, threatening the blood volume. It checks on. So this one, as it reduces slightly during upright posture, all these factors will decrease extracellular fluid volume, the volume of blood. Okay, so when there is the reduced extracellular volume, the kidney has juxtaglomerular apparatus, which are on stimulation It is a group of three types of cells: macular dense, glomerular cells, and many others. So the effect there I want to pick out is production of renin, and it cleaves angiotensinogen to angiotensin 1. Now angiotensin 1 flows through blood. When it reaches the lungs, it will be converted to angiotensin 2 by this enzyme, angiotensin converting enzyme. And angiotensin 2 has effects on the zona articularis cells, where it will stimulate release of aldosterone. So that is part of the synthesis, regulation of secretion of the mineralocorticoid. So let's continue. What are the roles of aldosterone as a hormone? One, depending upon the dietary intake of sodium, you just know this. The aldosterone secretion ranges from around 50 micrograms per day if the dietary intake is 150 milliequivalents, to around 250 if the dietary intake has reduced to 10 milliequivalents of sodium. Okay, so the plasma levels of aldosterone show daily variation, with the highest concentration at around 8 a.m. in the morning. That's when you have the highest secretion of aldosterone, and the lowest will occur at around 11 p.m. That is in the night. This is early in the morning. So in the night, aldosterone is lowest. Okay. So aldosterone has both primary and secondary roles, and the primary actions of aldosterone will include, has some effects on the renal tubules, and these are 4 and many. For example, look at this. It acts on the left distal tubules and collecting ducts of kidney nephron and causes following effects. 1. Sodium reabsorption from the tubular fluid into the renal tubular epithelial cells. And 2. Potassium excretion. In the kidney, there is active reabsorption of sodium, which occurs in exchange for potassium. That's why potassium will be excreted. So is hydrogen ions. So hydrogen ions are also excreted by this as sodium is being reabsorbed. And ammonium and magnesium excretion are also increased by aldosterone. Excretion of ammonium to go with these protons released. Okay, so let's continue. Effects on sweat glands, salivary glands, and colon. How does aldosterone affect these glands and the colon? Normally, the glands produce primary secretions which contain a large amount of sodium chloride. But this sodium chloride will be absorbed as the secretion passes through the ducts, and in turn, potassium and bicarbonate are excreted. So aldosterone will decrease loss of sodium and chloride in sweat and saliva. That's what it does. In the colon, the aldosterone stimulates sodium reabsorption from the colon while enhancing potassium excretion in feces. So potassium increases in feces, and sodium, much of it is reabsorbed within the colon. Colon absorption of electrolytes occurs. Okay, let's talk about the secondary effects. 1. Their effects on the plasma potassium concentration. For example, if there is a decrease in plasma potassium level, it can be as a result of aldosterone being excess. And a hypokalemia may occur in aldosterone excess due to increased urinary excretion of potassium. Aldosterone stimulates excretion of potassium, so it may cause hypokalemia if it is produced in excess. And if aldosterone is deficient, hyperkalemia might result. Okay. Effects on plasma sodium levels. Hypernatremia may occur if excessive aldosterone is released. And the hypernatremia has a couple of effects. One is increasing the volume of blood or extracellular fluid, and this may result into hypertension due to sodium and water retention. And in hyponatremia, excess sodium loss, tremia, which may occur due to excess sodium loss when aldosterone is insufficient or inadequate. Okay, so let's continue. There's a terminology called aldosterone escape, and I want us to talk about it. When there is hyperaldosteronism, or when you administer aldosterone for several days to normal individuals, the increased sodium and water absorption by renal tubules will increase volume of extracellular fluid, and hypertension will occur. However, after a 10 to 15 increase in ECF, there occurs pressure diuresis, that is excretion of sodium and water in urine, is increased in spite of continued action of aldosterone. So even though there is high aldosterone in blood, when the rise goes beyond 15%, there will not be more reabsorb. There will be excretion of sodium and water, which is a vice versa of what aldosterone is meant to do. So this phenomenon is what we call aldosterone escape, and probably is caused by secretion of natriuretic peptide ANP from the heart of the human being, from the heart. All right. So what is the contribution of adrenal glands towards sex steroid? Recall I said the Zona Articularis secretes androgens. So what is this contribution? One, during fetal life, adrenal cortex is hyperplastic and secretes a large amount of DHEA, which acts as the main precursor for synthesis of estrogens by the placenta. Okay? The placenta. It synthesizes estrogens from the DHEA produced by the adrenal cortex in the fetus. And in the adult women, this adrenal glands supply 50 to 60% of androgenic hormone requirement. DRS contributes to increased muscle mass, growth of pubic and axillary hair, and libido in women. So it has a role here: libido, axillary hair, growth of pubic hair also, and increasing muscle mass in women. In adults, it has those roles, and it is from the adrenal cortex. In the adult man, since testes produce a large quantity of testosterone, the adrenal androgen precursors are of little importance. However, they may be partly responsible for development of the male sex organs in childhood, around there, in childhood. But in the adult man, a lot of testosterone is being produced by the testes. So don't you forget to like our videos, subscribe, share, and subscribe for more and better videos, share. You can contact us and consult at david7santitheater@gmail.com. All right, thank you.